Good evening, Sriyuta.
Good evening, sir.
Fatma, you didn't attend for the physics class?
Yes, sir, I did.
You attended?
Yes, sir.
Okay. In last class, we are discussing about the alcohols. Is it right? Okay. In that one, we had seen preparation of the alcohols. Okay. And so today we will discuss about the chemical properties of the alcohol. What are the chemical properties of the alcohols, ma'am? Chemical properties of the alcohols. Chemical properties. The only important reactions we can discuss. Okay. What are the important reactions of the alcohols, ma'am? First of all, alcohols are it undergoes to the nucleophilic substitution reaction. Alcohols are it undergoes to the nucleophilic substitution reaction. Substitution reaction. Okay. And second one is alcohols are it undergoes to the reduction reaction. Reduction reaction. Okay. And third one is they undergoes to the dehydration reaction. Dehydration reaction. Okay. And they undergoes the oxidation reaction. Oxidation reaction. Okay. So all these are the different reactions. In this one, first I'm taking as a ethanol C2H5OH. Okay. C2H5OH. So for nucleophilic substitution reaction, I'll give one example. When the alcohol is treated with ammonia NH3, when the alcohols are treated with ammonia. The alcohols are treated with ammonia means what is the product it forms means here? It forms as C2H5NH2. It forms as a amines are going to be formed. Okay. And so alcohols are treated with the Lucas reagent. Lucas reagent. So what is the Lucas reagent first of all? What is the Lucas reagent? Lucas reagent is nothing but here anhydrous zinc chloride ZnCl2 in presence of concentration HCl is called as here Lucas reagent. So what is the Lucas reagent? Lucas reagent is nothing but here it is the anhydrous zinc chloride as well as here concentration HCl is called as a Lucas reagent. Okay. Now, so when here we have three types of the alcohols now. How many types of the alcohols are there for us here? Three types of the alcohols are there. What are the three types of the alcohols we are having means here? One is primary alcohol, secondary alcohol, and tertiary alcohol. One is primary alcohol, secondary alcohol, and tertiary alcohol. Okay. So primary alcohols are they does not give the positive test mark. Okay. By primary alcohols are they does not give the positive test. That means they won't form as a precipitate. So no precipitate is formed. No precipitate is formed. Actually, it is a confirmation test of the alcohols here. Okay. So Lucas reagent. With the Lucas reagent, primary alcohols are they won't give us a precipitate. Okay. So based on that one, we can say the given alcohol is primary alcohol. Secondary alcohols are they form as a precipitate within 5 minutes. Okay, so within 5 minutes they're forming as a precipitate. And tertiary alcohols. So tertiary alcohols are they give as an immediate turbidity. They form as a immediate turbidity. If they form as a immediate turbidity means, so based on that one we can confirm the given alcohol is tertiary alcohol. Okay, so same one also we can use. What is another confirmation test we are using in the detection of the alcohols, either primary, secondary, or tertiary means here? We can use as a Victor-Mayer test. Okay, we can use as here Victor-Mayer test. According to the Victor-Mayer test, primary alcohols are they give as a red color precipitate. Primary alcohols are they give as a red color precipitate. Secondary alcohols are they give as a blue color precipitate. They give blue color precipitate. And tertiary the alcohols are they give as a colorless. They give as here colorless. So tertiary alcohols are they give colorless precipitate. So now you got the clarity, ma? So what is the confirmation test of the alcohols means here? So one is reaction with the Lucas reagent. Second one is Victor Mayer test. Okay, and we have one more reaction also. What is the another reaction means? By passing the vapors of primary, secondary, tertiary alcohols on copper metal at 500 degrees Celsius. Okay, at 573 Kelvin. Okay, at 573 Kelvin. If you passes, so vapors of the primary alcohol, secondary alcohol, tertiary alcohol means, let us see. So primary alcohols are they converted into the aldehydes. Primary alcohols are they converted into aldehydes. Okay, secondary alcohols are they converted into ketones. Okay, and tertiary alcohols are they undergoes to the dehydration reaction. Okay, and they converted into alkenes. They converted into alkenes. So tertiary alcohols are they does not undergoes to the dehydrogenation reaction. This reaction also we can call as a dehydrogenation. Sir, what is meant by the dehydrogenation means removal of the hydrogen molecule. From the primary alcohol, if you remove one hydrogen molecule means it converts into the primary aldehyde. Okay, sorry, aldehyde. Okay, so when the secondary alcohols are passes, the vapors of the secondary alcohols are passes through the copper metal at 573 Kelvin. Okay, by removal of that one hydrogen molecule, it is converted into ketones. And tertiary alcohols are they form as here alkenes. Now we got the clarity. All
Yes,
these are
sir.
different identification tests, my dear. Okay. Now, what are the another important test we're having means esterification reaction. Esterification reaction we are using for the carboxylic acids as well as here alcohols also. Okay. Actually, esterification reaction is it is used to confirm the carboxylic acid. But by using that one also we can identify here. Okay, but we are not going to study under this chapter. That part we are going to study under here. So carboxylic acids. Okay, right, ma? Right. All
Yes,
these are
sir.
different tests we are having here. Next, reduction reaction. Okay, so what is the reduction reaction means? Ethanol only if it is reduced with the hydrogen iodide. Reduced with here hydrogen iodide in presence of red phosphorus means it forms as a alkyl iodide C2H5. I is going to be formed. Clear? Okay. And dehydration of the alcohol. If the alcohols are, they undergoes to the dehydration reaction. Dehydration reaction is nothing but removal of the water molecule. If you remove the water molecule, means they form as alkenes. C2H2. Ethanol is it undergoes to the dehydration reaction in presence of concentrated sulfuric acid. In presence of concentrated sulfuric acid means it forms as a ethene. The molecular formula of the ethene is C2H4. Okay. Next, oxidation reaction. Oxidation reaction. So we have a two types of oxidizing agents are there. For example, CH3 bond CH2OH is there. It is a primary alcohol. If you use the partial oxidizing agent, sir, what are the partial oxidizing agents we can use? Means here CrO3, chromium trioxide, okay, and PCC, PDC. Same reactions again we are going to study under the preparation of the carbonyl compounds. Here only we are going to be discussed. Okay, no, PCC, PDC, Jones reagent. Okay, JHO, NES. So Jones reagent. So all these are they act as a partial oxidizing agents. They convert the primary alcohol into aldehyde. They converted into the primary alcohol into aldehyde. That means ethanol is converted into ethanol. If we use strong oxidizing agent, sir, what are the strong oxidizing agent means here? KMnO4, acidified KMnO4. Okay, or acidified potassium dichromate, K2Cr2O7, acidified potassium dichromate. If you use the acidified potassium permanganate and potassium dichromate, they converted into the carboxylic acid, CH3COOH. Okay, if you use the strong oxidizing agents, means they converted into the carboxylic acid. If you use the partial oxidizing agents, means they converted into the aldehyde. So if you use the secondary alcohol, CH3 bond, CH bond OH bond CH3. If you use the secondary alcohol, if the secondary alcohols are treated with the partial oxidizing agents, means they converted into the ketone. CH3, C double bond O, CH3. Okay, but here, to oxidize the secondary alcohol with the constant, the strong oxidizing agent. Okay, so whenever the secondary alcohols are treated with strong oxidizing agent, it is also formed as a carboxylic acid, but carboxylic acids are formed by one carbon atom less. How many carbon atoms less, ma? It forms as here by one carbon atom less it is going to be formed. Okay, now so let's see what is the product it is forming. It forms as a CH3 COOH plus HCOOH is going to be formed. CH3COOH and HCOOH is going to be formed. Clear? Okay, so all these are the different types of the reactions we are having. Okay, ma? Next, we'll go for the preparation of the phenol. Preparation of phenol. Okay, so what is known as the phenol? We can call it as a phenol, ma. So which we can call as a phenol. And OH group is present on the benzene ring, means that we can call as a phenol. So phenols also we can call as a carbolic acid. Phenols also we can call as here carbolic acid. So what is another name of the phenol? Means carbolic acid. Okay, so we already had seen the classification also. If it is having one OH group, means what are the names are there? If it is having two OH groups, means what are the names are there? We had seen at the time of the classification. In this one, in phenols, OH group is attached to the sp2 hybridized carbon atom. In phenols, OH group is attached as sp2 hybridized carbon atom. Okay, now let us see how we are going to prepare as a phenol. What are the methods we are having in the preparation of the phenol? So we have to prepare as a phenol. How we can prepare as a phenol? OH. How we are going to prepare as a phenol? Okay. When chlorobenzene is treated with sodium hydroxide in presence of HCl, that is only we can call as here Dow's process. That is only we can call as a Dow's process. Okay, in Dow's process we can prepare as a phenol. How we are going to prepare as a phenol means here when chlorobenzene is treated with sodium hydroxide in presence of HCl, means it forms as a phenol. Okay, and what is the second method means here? By the decarboxylation reaction. Okay, so sodium salicylate. So what is the molecular formula of the sodium salicylate? Means OH bond COONA. If it undergoes to the decarboxylation reaction. So what is mean the decarboxylating agent? Means here soda lime. What is mean the soda lime? Soda lime is nothing but it is a mixture of sodium hydroxide and calcium oxide. It is a mixture of sodium hydroxide and calcium oxide mixture is called as a soda lime. If it is treated with the soda lime, means it converts into the phenol. It is converted into the phenol. Okay, next one. So what is the next method means here? Another method also it is there. From benzene diazonium chloride. From benzene diazonium chloride. When the benzene diazonium chloride is warmed with water. If you warm with water also it forms as a phenol. Okay. And what is the another method we are having means here? Raschig process also it is there. Okay. Raschig process. Raschig process. So what is the Raschig process means here? In Raschig process, benzene is first it undergoes to the oxidation reaction. Half mole of the oxygen. If it is treated with the half mole of the oxygen in presence of HCl, In presence of HCl means it is converted into the phenol. Okay. And what is the another important method we are having means here from cumin. From cumin. Sir, what is meant by the cumin means here isopropyl benzene. Isopropyl benzene is called as a cumin. This is the previous year NEET question also, and JEE also they asked here. Okay, so this we can call as a cumin. Okay, so when the cumin is, it undergoes to the oxidation reaction with oxygen. First, it forms as a cumin hydroperoxide. Cumin hydroperoxide. That means C bond CH3 bond CH3 bond CO bond OH. So this it forms as a cumin hydroperoxide. After that, cumin hydroperoxide, it undergoes to the intramolecular rearrangement reaction. That means OH group is it attaches with the benzene ring, and in between the carbon and oxygen it forms as a double bond. If it forms as a carbon and oxygen double bond means one is it forms as a phenol. What is the another product it forms means here acetone. CH3 bond C double bond O CH3. Okay, so all these are the different methods we are having in the preparation of the phenol. What are the physical properties of the phenol? Physical properties of the phenol. Physical properties of the phenol. Physical properties. What are the physical properties of the phenol is? Phenol is colorless crystalline solid. Phenol is, colorless crystalline phenolic smell solid. Phenolic smell solid. Okay, in this one. Here, phenol is insoluble in water. Phenol is partially soluble, but highly soluble in organic solvent. Highly soluble in organic solvents. Highly soluble in organic solvents. Okay, next. Here, so when it is exposed to the sunlight, so when the phenol is exposed to the sunlight and atmospheric air, when it is exposed to the sunlight and atmospheric air, it turns into the pink color. It turns into the pink color. How it is going to be done, ma? It turns into the pink color. Okay, right? Next, we already discussed about the chemical properties. So what are the chemical properties we already discussed means here, while studying the aromatic compound, there only we discuss about the phenol. So phenol is, it undergoes to the, which reaction, ma? Phenol is, it undergoes to the electrophilic substitution reaction. Why it undergoes to the electrophilic substitution reaction means on benzene ring, we have a electron donating group. If the electron donating groups are present on the benzene ring means it undergoes to the electrophilic substitution reaction at ortho and para positions. In this one, which one is the major product means here? So generally para one is the major product. I will give one question here. As per that one. Okay, as per that one here. So here one question it is there. So what is the question means here? We have an acidity of the phenols. Sir, here first of all, if the phenol, how we can going to be explain the acidity of the phenols means phenols are reacts with sodium metal. If the phenols are reacts with sodium metal means they form as a sodium phenoxide, ONA, and they releases the hydrogen gas. And second condition. So phenols are reacts with sodium hydroxide also. If they react with the sodium hydroxide means they form as a sodium phenoxide plus water molecule. But they does not react with sodium bicarbonate. Okay, there is no reaction of the phenols with here sodium bicarbonate. Okay, so all these reactions are explained the acidity of the phenols. All these are explained here, acidity of phenol. So what is another main important point, exam point of view questions means here? So phenols are acidic in nature only. The acidity of phenols are directly proportional to electron withdrawing groups, okay, and inversely proportional to electron donating groups. Number of electron donating groups are increases, acidic strength is going to be decreases. Number of electron withdrawing groups are increases, their acidic strength also is going to be increases. At the same time, acidity of the phenols is directly proportional to Ka value and inversely proportional to pKa value. Sir, what are the examples for that one means here? Exam point of view question, ma? Actually, one question I'll ask here. So, what is the question means here? So, based on this one, 2-3 questions are there. Now, my question is, orthonitrophenol is there and para-nitrophenol. Orthonitrophenol and para-nitrophenol. So, which one is more stable? Which one is more stable? And which one is more acidic also? Two questions are there based on this one. 2-3 questions are there. First one is, I'm asking the stability. Which one is more stable? Actually, we can consider as a para one is the major product. But in this condition, which one is the major product means? So para-nitrophenol is the major product. Sir, why you are telling that para-nitrophenol is major product and sorry, orthonitrophenol is the major product and para-nitrophenol is minor product? Why means in orthonitrophenol, phenol is it undergoes to the intramolecular hydrogen bonding. Whenever it forms as an intramolecular hydrogen bonding means it forms as a chelating rings. So chelation is nothing but formation of the cyclic ring. The number of cyclic rings are increases, their stability also is going to be increases. Number of cyclic rings are increases, their stability also is going to be increases. Due to that reason only orthonitrophenol is more stable. Okay. After that, para-nitrophenol. And one more question, exam point of view question. How you are going to separate the orthonitrophenol and para-nitrophenol? So what is the method we are using? Which method we are using means here, orthonitrophenol and para-nitrophenol can be separated by steam distillation method. Steam distillation method. Sir, why we are going to separate the steam distillation method means here, because of orthonitrophenol is having low boiling point temperature while comparing with the para-nitrophenol. Sir, why the orthonitrophenol is having the low boiling point temperature means due to the presence of intramolecular hydrogen bonding. Due to the presence of intramolecular hydrogen bonding. Okay. And so why this means here, why the para-nitrophenol is having high boiling point temperature means due to the intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Hydrogen bonding. So this is the reason. Okay. So all these are the exam point of view questions. Okay. And one more question is there. So what is the another question they're asking means here, what is the reactivity order of the phenols? Let us say they are giving us some structures. So what is the structures they are giving means here? For example, if para position nitro group it is there. Okay, OH and NO2 group it is there. At the same time, one more they had given. So what is another one means here? Para hydroxy methyl CH3. Okay, and what is another one means here? In this one, OH bond phenol. I'll take as a phenol. So which one is more acidic in this? Three structures I had given. Which one is more acidic? I had given three structures. Can you write the increasing order or decreasing order of the given structure? Acidity of given compounds. Acidity of given compounds. Which one is more acidic? Either first, second, or third? In this one, first one is more acidic. First one is more acidic. After that, third one. After that, second one. Sir, why the first one is more acidic? Means strong electron withdrawing groups. According to the statement, so electron withdrawing groups are increases. Their acidic strength also is going to be increases. Okay, so that's why first one is more acidic. And electron donating groups are decreases the acidic strength. So that's why second one is the least acidic. Okay, so phenol is more acidic because of it is not having neither electron donating group nor electron withdrawing group. And one more question, previous year question only one. So what is the previous year question they asked means here? In this one, orthonitrophenol OH bond NO2, 2-nitrophenol. Next one is 2, 4, 2, 4 dinitrophenol, and third one is OH bond NO2 bond NO2 bond NO2. So based on this one, we have a 2 questions in the exam point of view. First of all, my question is, which one is more acidic? Which one is more acidic? First, second, third.
Third.
Which one, ma? Third one is the more acidic. Because of number of electron withdrawing groups are increases, the acidic strength also is going to be increases. So that's why third one is the more acidic. Okay. And what is another question means here? Which of the following molecule is highly reactive towards to the nucleophilic substitution reaction? Which of the following molecule is more reactive towards to the nucleophilic substitution reaction? Which of the following is more reactive towards the nucleophilic substitution reaction? Number of electron withdrawing groups are increases. The reactivity towards the nucleophilic substitution reaction also is going to be increases. According to that one, which one is more reactive means here? Third one is more reactive towards the nucleophilic substitution reaction. Got it?
Yes, sir.
Okay. And so what is another question they're asking MSET level means here? What is the structure of picric acid? What is the IUPAC name of the picric acid? So which we can call as a picric acid means here 2, 4, 6 trinitrophenol. 2, 4, 6 trinitrophenol is called as a picric acid. Sir, where we are using as a picric acid means here, picric acid can be used as an explosive. It is used as here, explosive. Okay, clear?
Yes, sir.
Right, ma? So these are the some different reactions and some important points about here, phenol. Okay, and in this one, some reactions also is there. So where we are using as a phenols means phenols can be used in the preparation of the aldehydes, salicylaldehyde. Okay, so phenols can be used in here, preparation of the salicylaldehyde. Okay, and Riemann-Tiemann reaction, some named reactions are there. So in that one of the important reaction is here. So Riemann-Tiemann reaction. So what is the Riemann-Tiemann reaction, ma? What is the Riemann-Tiemann reaction means here? When the phenol is treated with chloroform CHCl3 with alkaline solution with KOH. Okay, if the aqueous KOH means finally it forms as a salicylaldehyde. It forms as here salicylaldehyde. This we can call as here salicylaldehyde. Salicylaldehyde. Okay, this also we can write as here 2-hydroxybenzoaldehyde. This also we can write as 2-hydroxybenzoaldehyde. Sir, in this one, so what is the reaction intermediate in this reaction? Actually, this reaction is example of electrophilic substitution reaction. The reaction is example of electrophilic substitution reaction. Substitution reaction. The given reaction is example of electrophilic substitution reaction. So what is the electrophile in this one means here? Dichlorocarbene. Dichlorocarbene is the electrophile. CCl2. Dichlorocarbene is it act as a electrophile. Okay, this is the one reaction. Okay, next Getterman reaction. Getterman reaction. So what is the Getterman reaction means here? When phenol is treated with hydrogen cyanide in presence of HCl. Okay, hydrogen cyanide in presence of HCl, in presence of AlCl3 also, it forms as here and hydrolysis H2O plus H plus. Okay, hydrolysis reaction means it is also formed as a salicylaldehyde. And what is another one is Getterman-Koch reaction, it is there. So what is the Getterman-Koch reaction means? In this one, OH and carbon monoxide in presence of HCl, the reaction is carried out in presence of AlCl3. It is also formed as a salicylaldehyde. Okay, it is also formed as here salicylaldehyde. So all these are the different named reactions of them. So last one is called as a Getterman-Koch reaction. Getterman-Koch reaction. So all these are the some important reactions. Okay, right?
Yes, sir.
Okay, so next, so we'll discuss about the ethers format. So we'll discuss about here ethers. Ethers. Right, ma'am. So ethers. What is mean by the ethers means here? What is the general formula of the ethers? What is the general formula of the ethers? What is the general formula of the ethers, ma'am? Shriyata? Do you have any idea about the general formula of the ethers?
R
bond, O bond R is called as a ethers. Okay, sir, how you are going to prepare the ethers means here? So two important methods we can discuss here. From alcohols, ma'am. So 2 moles of the ethyl alcohol, CH2, C2H5, OH. 2 moles of the ethyl alcohol is treated with concentrated sulfuric acid. Treated with concentrated sulfuric acid at greater than 140 degrees centigrade, ma'am. Greater than 140. So directly if you want to tell means at 170 degrees Celsius. Okay, 2 moles of the ethyl alcohol is heated with in presence of concentrated sulfuric acid at 170 degrees. It forms as a diethyl ether. C2H5 O bond C2H5. It forms as here diethyl ether. Okay, clear? And what is another
Yes,
method?
sir.
What is the important method we are having means here? Williamson synthesis reaction. Williamson synthesis reaction. So by using the Williamson synthesis reaction also, we can prepare symmetrical ethers or unsymmetrical ethers also. It is one of the best method to synthesize the symmetrical and unsymmetrical ether. Okay, so Williamson synthesis reaction is follows the SN2 reaction mechanism. Follows here SN2 reaction mechanism. Okay, now, sir, how are you going to prepare as a symmetrical or unsymmetrical ethers means? For example, let's see, if you are taking ethyl sodium ethoxide, when the sodium ethoxide is treated with ethyl chloride C2H5Cl, if it is treated with the ethyl chloride means by removal of the NaCl, it forms as a diethyl ether. C2H5 bond, O bond, C2H5 plus NaCl. So these we can call as here symmetrical ether. Sir, why we are calling as a symmetrical ether means both side identical groups are there. Whenever it is having the both side identical groups means that we can call as a symmetrical ethers. Okay. Next, we can prepare as unsymmetrical ethers also. Sir, how we can prepare as unsymmetrical ethers means if the reactants we can take as a different one here. Okay. For example, if I am taking as a sodium isopropoxide, sodium isopropoxide, or I can take a CH3 bond, C bond CH3, CH bond ONA. If it is treated with ethyl chloride, Cl bond C2H5. If it is treated with the ethyl chloride means it forms as a CH3 bond, CH bond, OH bond, O bond C2H5. Okay, O bond C2H5. This only we can call as a ethyl isopropyl ether. Ethyl isopropyl ether is an example of unsymmetrical ether. Okay, so these two are they follows the SN2 reaction mechanism. Exam point of view question mark. Okay, in the preparation of the tertiary butyl ethers, what are the reactants we are adding? In the preparation of tertiary butyl ethers, what are the reactants we are adding means here to prepare the tertiary butyl ethers means we have to use as a CH3 bond CH3 bond ONA plus Cl bond C2H5. Then only it forms as a tertiary butyl ether O C2H5. In case if you had taken Cl CH3 bond CH3 bond CH3 plus O Na bond C2H5. If you use this one means it forms as an alkene CH3 bond CH3 double bond CH2 plus C2H5 OH plus NaCl is going to be formed. Sir, why it is formed as a alkenes on behalf of the ethers means because of sodium ethoxide is the weak base one. Okay, so it is the weak base. So conjugated weak acid alcohols are they are the weak acids. Then their conjugated base is strong. If the conjugated base is strong means it has a high tendency to abstract the proton from the neighboring atom on behalf of substituting reaction. On behalf of nucleophilic substitution reaction, they undergoes to the elimination reaction. Due to the elimination reaction only it forms as here. Due to elimination reaction only it forms as here alkene. Now you got the clarity. So what's the difference? It is exam point of view question. What are the reactants we are using in the preparation of the tertiary butyl ethers means here sodium tertiary butoxide plus alkyl halide if it treated means it forms as a sodium tertiary butyl ether is going to be formed. We need not to take as a tertiary butyl alkyl halide. Got the clarity? And same one only important question. So what is another question means here in the preparation of aromatic ethers. So what we have to take means here we have to take as a sodium phenoxide. If ONA is treated with ethyl chloride C2H5, then only it forms as a phenyl ethyl ether, or this only we can call as a ethoxybenzene. Okay, and we can't take as a haloarine. Okay, C2H5 ONA. The reaction is not possible. Why means aryl halides are less reactive towards the nucleophilic substitution reaction. So what is the reactants we have to take means here? We have to take as here only sodium phenoxide. And exam point of important question here. So what is the question means here? Ethers are react with hydrogen iodide. Ethers are react with hydrogen iodide. For example, CH3 bond O bond CH3. If it is treated with the hydrogen iodide means one is formed as an alcohol, another one is converted into the methyl iodide. So one is converted into the alcohol, another one is converted into the halide. Okay, so when you give this kind of product means whenever they are symmetrical. If it is unsymmetrical means, for example, ethyl methyl ether. O bond CH3. If it is treated with hydrogen iodide, if it is treated with the hydrogen iodide means, let us see, in this one, iodine is going to be attached to the lower alkyl group. Lower alkyl group means on which side you are having the less number of carbon atoms. For that one, iodine is going to be attached, and another one is converted into the alcohol. That means it forms as a methyl iodide plus another one is converted into the alcohol. That means it forms as a C2H5OH. Same reaction we are applying for tertiary butyl ether. Okay, it is the exception case, it is the exception case and special case also. In this one, iodine is going to be attached to the tertiary butyl carbon atom and it is converted into methanol. Sir, why it is attached to the tertiary butyl carbon atom only means here? Because of in this one, it forms as a tertiary butyl carbocation. Tertiary butyl carbocation is more stable. It is more stable. That's why iodine is going to be attached to the tertiary butyl carbocation. This is the previous NEET question also. And one more question. Anisole. If the anisole is treated OCH3, if the anisole is treated with the hydrogen iodide means it forms as a phenol. Forms as a phenol. And methyl iodide is. So these are the exception exam point of important reaction of from alcohols, phenols, ethers. Okay, until here clear, ma? Srita? Is that clear?
Yes, sir.
And tomorrow we'll discuss about the aldehydes, ketones, carboxylic acid. Only important points we'll discuss. Okay, ma?
Yes.
Right, ma. Then we'll continue in the next class.
Okay, sir.